this lesson, we are going to discuss about basic SQL. So let's first look at some history about this structured query language. So it was first developed in 1970s by the IBM company, and at that time it was called SQL. And later its name has changed to structured query language, or as we commonly known now as SQL. And ANSI and ISO standards groups has now officially accepted SQL as a standard. And the latest version for this SQL standard is published in 2016. Most of the commercial systems available may not support all of the features defined in this latest standard. So if we find out that any of the codes that we discuss here to be not working, so that would be the reason. So this SQL, so the structured query language has several parts. As we have already discussed in our first lecture, we know about the data definition language, or the DDL, that basically provides the definition for the relational schema or the database tables. And then it has another part, data manipulation language, which basically provides the ability for us to query information from the database, or even insert, delete, and update records. So the DDL and DML are both part of SQL. So first we will look at the data definition side of SQL. So using this SQL commands available, we can define the schema for each relation. So in a few minutes, we will see how to do that. And we also can define the types or the domain of each different column in those relations, and different integrity constraints, as well as what we will later learn as index or indices that is going to be maintained for each of these relations. So first, we will look at what are the domain types available in SQL. So if I remind you again, domain means the possible types of values a particular field or a attribute in a table can have. So there are a lot of different types or domain types that we can use with SQL. And first we have char, or we call it as char, that is simply for characters. When we have the domain type as char, we can specify a value n, which is the length or the number of characters that we can have in that field. So that would be a fixed length character string. And then we have varchar, or variable characters. So that is basically a variable length character string with user defined maximum length n. So it can have less than that, but not more than the n. And then of course we can have integers. In SQL we simply call it as int, and it has a machine dependent size. So typically that would be 32 bits or 64 bits depending on the machine architecture. And we also have another one called small int, when we don't need a 32-bit or larger integer. When we want to store a smaller number, we can simply have a small int. So again, it's a subset of integer type. And then we have numeric, which is a fixed point number that can have decimal places. So we can specify how many digits or precision we want after the decimal point, and how many total number of digits we need to have for the number. So if you want to simply define something like a currency value, let's say for maybe for a rupee amount, we can simply have the D as number 2, since we need 2 decimal places for the cent value. And then we have floats, which is a floating point number. with at least n digits. And there are a lot of other different types that I have not mentioned here. You can simply check for a SQL documentation online and you will find there are like 100 different types of domains. So as the first step, we will see how we can create a table with SQL, how to define the schema for a table. So there's a simple syntax, how we can write that in SQL. There's a special command called create table. So as you can see in this syntax example here, the statement should start with create table followed by the whatever the table name. So we can specify any name here and then followed by a list of columns within brackets. So we can have column 1 followed by whatever the data type, column 2 followed by whatever the data type, and so on. So data type would be one of those that we discussed and all the possible different domain types. So let's see an example for that. Let's say we want to create a table for persons and a person have a ID, a name and age. So this is how we can simply define that. We have the first column name as ID int, which means the column name is ID and the type of that would be integer. Then followed by a comma, we have the second column name and the type would be varchar 64. So that means we can have a maximum number of characters 64 as the name, and anything less than that should be okay. Then the third column would be age, and again it's an integer. And then we close the opened parenthesis and end with a semicolon. This is the whole SQL command or the query for creating a table. And then we have certain integrity constraints that we can impose when we define the table or the relation. So what we mean by integrity constraint is certain, let's say, rules that these relations should follow. So there are a few different types of integrity constraints that we can have. We can specify a particular column as not null. So that basically means the column should not have null values or empty values. And then we can define the primary key for a certain table as well as foreign keys. So this is how we can apply these integrity constraints. So we have the same table as we saw in the previous slide, create table persons, and followed by the first column definition ID int, we have specified a special constraint not null. And same for the name varchar field. So what that means is this ID and name columns should not have null values. So that means they should always have any kind of a value, but not null. And as the after the age column definition, we have now included the special line primary key ID. So what that means is we have specified that our ID column should be the primary key for this table. So if you remember, that means this ID column should not have any duplicate values for two records. So any value in ID should only appear in a certain single record or a row. As we defined or created a table, there should be a way to remove a table as well. So if we find out that a certain relation is not used anymore, we can just delete. There should be a way to remove it. So the syntax for that, or the command in SQL, is drop table. So we can use drop table command simply followed by the table name and end with a semicolon. So if we want to drop the persons table we just created, we can use this SQL command drop table persons followed by a semicolon. And then there's a way to alter the tables we have created as well. So for the command for that would be alter table followed by the table name. And then if we want to add a new column to the table, we can use add column name and the domain type. Or if we are going to remove a certain column, we can use the same notation, alter table, whatever the table name, followed by drop column, and then the name of the column we want to drop. Two similar commands, but depending on what you want to do, the last line is different. So in these SQL commands provided here, these blue colored ones are the actual keywords in the syntax. So all in the black type is what you can change. So table name, you can specify whatever the name you want, and column name as well as the type. So here we have two examples. In the first one, we are adding a new column to the person's table called phone, and that's going to be a varchar column of 12 characters. And then if you want to just drop that new column, you can simply say alter table persons and drop column phone. This SQL is not usually case sensitive. That means although I have specified these keywords in capital letters, it is not a must. Even if you mention them in simple letters, it will work. But usually when as for the our convenience, we as a practice we use capital letters for the keywords and simple words for the whatever the table names and column names and other things. So that when you look at the SQL query, it makes it easier to just get the idea what this query is doing. So now what you have to do is go to this SAM folder wherever you installed it and MySQL, and inside the bin folder, and this is where I want to open the command prompt. So I'm going to press CMD again. So now I'm here, right? SAM MySQL bin folder. So if you have got this, now all you have to do is type here the mysql.txt and followed by user equals root and password equals, and I'm just going to leave it empty. So what we have specified here is I'm starting a session with our MySQL server, and I have provided the username as root and the password as empty. So by default in this SAMP MySQL server, the username would be root. So when you just install it, the default username is root and there's no password. So that's what I have mentioned here. And now I'm gonna hit enter here. So I have misspelled password here. There should be 2S. And now it has logged me in to the MySQL server. So if you have done it right, you should get this kind of a informative lines, and now the prompt is waiting with this MariaDB. So just don't worry about that, what that MariaDB means. And this is where I can enter SQL queries. So as the first step, let me check what are the databases I have. So there's a simple command for that, show databases. And this command prompt shows you that there are 21 databases available currently in my MySQL database. So in your case, usually there would be only 3 since you haven't created any databases yet. Okay, now let's try to create a new database. So let's type the command for that, create database, and call our new database as tutorial1. So now it says you get a response query okay, 1 row affected. So if I check again what are the tables I have, so now we're gonna see our new database tutorial1 has created here. Right, so earlier we had 21, now we have 22. So what should happen if I try to create the same database again? So I get an error saying that I can't create the database tutorial1 because it already exists. I can't create 2 databases with the same name. So if you get an error like this when you are doing something, just look at the error message, and most of the time that should be pretty straightforward to understand what you have made wrong. So now let's try to create this persons table we had in our slide. So let me start with create table. So again, this doesn't have to be capital letters, but simply for my preference, I'm going to use capital letters for keywords. So create table persons, and I'm going to open the bracket. And the first column should be ID int, not null. And finally, I'm going to use the primary key constraint. So I want my primary key to be the ID column. So and at the last line, I'm going to close this open bracket, and to end this SQL statement, I have to use the semicolon. Otherwise, if I don't type this, it will expect another line. So only if you type the semicolon, the SQL will know that that's the end of the query. Right. So I get an error saying that I didn't select the database. So there's one command that I should have used before typing this. That is basically MySQL doesn't know in which database it has to create this table. So to select the database, there's a command called use. So I'm going to say use tutorial1, the database that we just created. Right, now we are inside that database. So I'm gonna have to retype all this, but fortunately within this command prompt you can use the arrow up and down keys to get something that you have already typed. Right, so I get the message query OK, 0 rows affected. So now let's check what are the tables available in this particular table. Sorry, this tutorial 1 database. So I use the command show tables, and I got this response, tables in tutorial 1. So we have only one table in it, that is persons table that we just created. Right. So I just show you the first steps, and now you can continue from here. Right. So similar to what I did, you can just do whatever you want. You can create more tables with whatever the name you want and any number of columns as you prefer. And you can try deleting some of these tables and altering some of them and all sort of things. So what we just show was using SQL for data definition as a DDL. But we know that SQL is capable of doing data manipulation as well. So we will now see instructions like insert, select, and update. So once we created tables, there should be a way to add or insert data into that. Otherwise, there's no use. So to insert this data, there's a simple query syntax. So we start with the keywords insert into, followed by the table name, and then followed by the list of columns within brackets. And again followed by that with the keyword values, and then whatever the values that we want to be inserted into those columns that we mentioned. So that should be in the exact same order. So that means value 1 would be the one that is inserted into column 1, and value 2 would go to column 2. So we have to make sure that whatever the order that we mention the columns, that should be the same for values as well. Otherwise, we will end up with wrong values in the wrong column. So let's see an example how we can insert a record or a row into the persons table we just created. So we are going to write it as insert into persons, and within brackets ID, name, age, the 3 column names, and values are going to be 10, Adam, and 22. So you can have whatever the values you want. And another example, so the same table insert into persons. So we don't have to always specify all the columns available in the table. If you want to have a null value in a certain column, we can just omit it. So in the second example, we have ID, name, and 2 values that should go into those columns. So I'll leave it for you to try these things out. The same way I have shown you, you can just type these into the console and try these things out. And there's an even simpler version for the same insert query. In case if you are inserting values for all the columns, you just don't have to mention the list of columns. So you can simply write it as insert into table name values followed by a list of all the values. But you have to make sure that you are providing these values in the same order as the columns appear in the table. Right? So SQL will figure it out which value is going to which column, and you have to provide same number of values as you have columns in the table. So since we have 3 columns in persons table, we have to provide 3 values. Otherwise, SQL will complain that you are missing a value for certain columns. And then let's see how to query data or get data from the database. So for that, we have another keyword or a command called select. So the basic syntax for that is we start with the select command, then we can specify which columns we want to get, and followed by keyword from and the table name that we want to get data from. And when we execute this SQL query, what we get is called a result set. Right? Since it's a select query, we should get a result back from the database. So that is called a result set. And if we want to include all the columns from a particular table, there's a simpler way to do that without specifying all the column names. We can just mention or specify a star or the asterisk symbol. So select this asterisk from whatever the table name. Although we write it as asterisk, when we read it, we usually call it as select all from table name. Right? So if somebody says select all, that usually means select the asterisk symbol. So let's say in our persons table, there are some records. And if you write a query, select ID command name from persons, this first table would be the result set that you get. Only the ID and name columns. And if you write another query, select all from persons, you should get all the columns available in the persons table. So in this case, we will get all 3 columns. And there are some special keywords that you can use with a select query. For example, let's say you only want to select distinct values from a particular column. So for example, even in our persons table, we saw that we had 2 people with the age 21. So these are duplicate value. So for some reason, if you want to find out what are the distinct different ages that these persons have, you can use a keyword like distinct. So same structure, only thing is we mention select distinct whatever the column names. So in this case, if you use write a query select distinct age from persons, we should only get the age column since we haven't mentioned the other columns, and we will only get all the different values for age. Right, so you can see that although we had 4 persons in the original table that we considered here, in this query result, we have only 3 rows because 21 is repeated. So there's only 1 record for that. Now, when you write a select query, just getting all the records in the table is not very useful. most of the time. So there should be a way to filter the records as we want. So that is done by using a where clause. So by using a where clause, we can specify a condition, and only the record satisfying that specified condition will be returned in the result set. So we can specify this where condition after the select query at the end. So select whatever the column names from table, where, and the condition. So let's see an example for that. Let's say we want to select the person with the ID 12. So we can simply write it as select all from persons followed by where ID equals 12. And we should get the result as this. Only the record which has the ID as 12. And if we simply write another query, select all from persons where age greater than 20, we should get 3 records in this scenario, in this example table, where the records have an age value greater than 20. So we can use these operators with the where clause, equal and not equal sign, greater or greater than equal, less than and less than equal, and also this between, like, and in commands. So I'm not going to cover all of these. You can just refer to a documentation online, and there will be plenty of examples for them. But you can see that it's pretty straightforward, very much like what we are used to with Python conditions. And of course, like in Python, we can actually combine these conditions as well. So we can use AND operator and OR operator to combine 2 or more such conditions. So you can have where condition 1 and condition 2, or condition 1 or condition 2, or even 3. And there's another operator called NOT. If you want to get the negation of a particular condition, where not condition, so that would be the inverse of the condition. For example, if you simply say where not age greater than 20, you should get the inverse of that, which is all the people with age less than or equal to 20. So there are a few examples for that as well. We have select all from persons where ID is greater than 12 and ID is less than 15. So we should get all the people with IDs between 12 and 15. There's only one. And if we say where ID is 12 or age is less than 20, so again, we should get the records that satisfy either ID equals 12 condition or age less than 20 condition. And similarly, if we say age not, sorry, where not age equals 90, so we should get pretty much all the records which doesn't have age value equals to 90. Right, so that is about selecting data from the database. Now let's see how we can update existing data. For that we have another keyword called update. So the syntax would be update the table name, and then we have another command or a keyword called set, followed by the columns and the values. So we write it as update table name, set column 1 to whatever the value, comma column 2 equals another value, and so on. And usually we will have a where clause as well. Otherwise, if we simply say update table and set whatever the columns and values, it will update all the records, all the rows in the table with the given values. So that is not what we usually want in except for in rare cases. We would normally want a particular record to update. So to make sure that only the intended record is updated, we can use a where condition. For example, if we want to update this person with the ID 12, we can say update persons, set name equals to Jenny and age equals to 23, and followed by where ID equals 12. So using that where clause, we have make sure that only the record satisfying that condition will be updated. If we didn't have that where clause, all the records will be updated. And you can see, as in the second example, if we say update person, set age equals to 30, where age greater than 20, all the records that has a age value greater than 20 will be updated to the new age value of 30. So you can see these blue colored highlighted records are the ones that got updated. Right, and finally, so we have learned to select data and update data, insert. So finally, there should be a way to delete them as well. So again, that's very similar to what we already have seen. We have delete command. So the syntax would be delete from the table name followed by a where condition. So again, where condition is optional, but unless you want to delete everything from a table, you have to specify a condition. If you simply say delete from table name, it will delete all the records. But that is not something we want usually. So for example, now we earlier had the person with ID 20 called Kevin, and if we want to delete him, we can simply say delete from persons where ID is equal to 20. So you can see now that Kevin with ID 20 record is deleted. And if we say delete from persons where age is greater than or equals to 21, all the records which has a age value greater than or equal to 21 will be deleted. So only one record will be left. So as you can see, delete is something that you have to use with care. Otherwise, you might end up deleting unwanted records. And once you deleted something from an SQL database, there's no way to get that back. So there's no undo. If you delete it, that is gone.